that we here highly resolve that these dead shall not have died in vain, that this nation under God shall have a new birth of freedom, and that government of the people, by the people, for the people, shall not perish from the earth.
Dr. Sheldrake is one of the world's most innovative biologists and has revolutionized scientific thinking with his vision of a living, developing universe with its own inherent memory. He first worked in developmental biology and is best known for this theory of morphic fields and morphic resonance. His latest book, The Sense of Being Stared At, develops his concept of the extended mind. I'd like you to put your hands together and welcome Mr. Rupert Sheldrake.
Thank you. Well, thank you. You've been plunged right in at the deep end this morning with an experiment. You've got in your hands, I hope, some sheets of paper that are probably all Greek to you. I'm going to ask you to take part in a very simple experiment before your minds are contaminated with theories or expectations. We're going to plunge straight in. This only takes a couple of minutes, and then we'll get to the nature of the universe. But we're going to start with something more mundane, namely a scientific experiment. You are going to need a pencil or pen for this, so if you haven't got one, I haven't got one either. And so I'm afraid you're going to have to borrow one from your neighbor if your neighbor's got one, and if not, you'll have to borrow it from the next but one person, take turns. What's going to happen here is, first of all, please fill in the front of the form with 3 simple questions. Sex, age, and can you read Greek or not? Now, when you've filled that in, could you close the little booklet so that you're not looking at the Greek words? Okay, anyone not ready? Okay, what's going to happen now is that I'm going to show you 8 Greek words on this screen, and you'll be looking at them for 10 seconds. After that, if I can manage the technology, they'll disappear. And then you're going to open the little booklet and I'll tell you what to do. Okay, so look at the screen. And the words should appear now. Okay, look at the words. You're going to try and remember them. Doesn't matter the order, just try and remember them. Okay. Now, open the little booklet and circle 8 words on that first sheet. Try to circle the 8 words you've just seen. If you can't remember them, you'll have to guess. But circle 8 words altogether. The first of the pages, the one that you immediately see when you open the little booklet. Okay. Anyone not finished? All right. Now, what's going to happen is you're going to see the same 8 words again in a different order, and you're going to have another chance to remember them. And then you're going to turn over to the back sheet and circle another 8. So you don't need to turn over yet. Just concentrate on the 8 words that will appear on the screen in a few seconds. 4, 3, 2, 1, now. Okay, so now please circle 8 words on the last sheet, on the back of the little booklet. Good. So hopefully you've finished now. Could you pass them all to the end of the row, please, and we'll collect them up. That's the experiment's over. Okay. Well, thank you very much. I'll explain what you've just done a little bit later. But that was an experiment in morphic resonance, and I'll explain exactly what it was later. This is, as you see, a very simple test. It has huge implications, but I'll wait until I've explained a bit more about the theory so I can explain the test. What I'm going to do this morning is talk about memory in nature, the idea that the laws of nature are more like habits. And I'm going to talk about morphic resonance and the collective memory, which is inherent in all species. This is, at first sight, a very radical hypothesis. But what I'm going to argue is that this is something that we're all going to have to think about whether we like it or not. Because science is in a state of crisis. Two of the most fundamental paradigms or models of reality in science have come into head-on collision with each other. Most people don't realize it's happening because it's happening slowly. It's more like two great tectonic plates colliding, and when they collide, you don't notice anything. Then there's an earthquake or a volcano or something. These two tectonic plates of theory are crashing into each other, and they're going to force us to change our worldview. Now, I think that the change they're going to bring upon us is a change towards the idea of a memory in nature, the whole of nature, the whole universe, having a memory. In order to put it in context, I'm going to talk about these two worldviews. And this involves a sort of fast forward through 2,500 years of intellectual history in about 5 minutes. So you're going to have to fasten your seat belts for this. What I'm going to do is show how these two fundamental models that we've all inherited, that we've all got part of in our psyche, are in collision and are going to force theoretical changes. The two fundamental models I'm thinking of are ones that we've inherited from the Greeks and the Jews, the two main ingredients of Western civilization. They are the ideas of eternity, the idea that nothing really changes, and the idea of evolution, the idea that everything changes and develops in time. The idea of eternity is something we inherited from the Greeks. The ancient Greek philosophers were obsessed with the idea that behind this world we live in, there's a timeless realm, a realm where nothing really changes. They probably got this idea from mystical experiences. Lots of mystics through the ages have said they've experienced a realm beyond space and time. The Greeks may have been influenced by mystery cults, mystical groups of people, influences from Asia, we don't know. But the fact is that the Greek philosophers were each trying to find their own solution to the mystery of eternity. They came up with different answers. Pythagoras and his school came up with the idea that the ultimate eternal reality is mathematical, that behind the world of appearances there are eternal mathematical truths, ratios and proportions and harmonies which are true everywhere, at all times and in all places. Plato generalized the Pythagorean insight and had the idea that behind everything in the world there's an eternal archetype. Every horse, for example, is a reflection of an eternal horse idea, an imperfect reflection of an ideal form or archetype of the horse. And this is the realm of Platonic ideas or forms, usually written in philosophy books with capital I or capital F for ideas and forms, so you realize it's not just the regular use of the idea, of the notion. So those were two ideas that said that the eternal reality is beyond space and time, outside space and time, essentially living in some kind of eternal mind. The atomists or materialists came up with a different answer. They said that the only reality is matter, and matter is made of lots of little bits called atoms, and these endure forever. And the changing world we live in is because of the changing combinations and movements of the atoms moving in a void. So for them, matter was the eternal reality. And then Heraclitus, who was a kind of maverick among Greek philosophers, said that the only thing that remained constant was change itself. Well, he had less influence, but the Platonists and Pythagoreans had an enormous influence on Western philosophy. As Christianity took off in the Eastern Mediterranean, it had to be brought into relationship to the prevailing Greek philosophy. Christianity developed in a Greek world. The New Testament is written in Greek. And with the language of the New Testament comes the whole implicit philosophy of the Greeks. And it was relatively easy for early Christian theologians like St. Augustine to see how the Platonic philosophy could be fitted into a Christian theology. The Platonic forms or ideas were none other than ideas in the mind of God, aspects of the Logos, the second person of the Trinity. And God thought these ideas eternally. So that was a fairly easy assimilation. Platonism was somewhat eclipsed in Europe in the Middle Ages by the rival school of Aristotle. But at the Renaissance in Europe, there was a big revival of Platonism. And European intellectuals got very excited again about this eternal reality behind space and time. The founding fathers of modern science were all Platonists or Pythagoreans, believing that the ultimate reality is essentially eternal, mathematical, beyond space and time. They thought that the so-called laws of nature were eternal mathematical ideas in the mind of God, and that scientists could actually reveal or read the mind of God through discovering these mathematical laws. So when Newton came up with his law of gravitation, this wasn't seen as just a temporary human model. It was seen as the unveiling of the mind of God, the eternal mathematical truths in the mind of this mathematical God. The idea that God's a mathematician is perennially popular among mathematicians. And of course, of all people, it makes them closest to the divine. So this was a very influential idea, and at the Enlightenment, the end of the 18th century, when there was this cult of science and reason, the idea that human beings could understand ultimate truth was a very big part of that. In the 17th century, there was also a revival of atomism, the philosophy of Democritus. And the idea was that matter is made of lots of little bits, atoms. And basically, 17th century science, which laid the foundations for the sciences that we now have, was a kind of cosmic dualism of material atoms governed by eternal laws which were beyond space and time, that were themselves not physical. But they governed the physical atoms. No one explained quite how, but that was what was laid into the foundations of science, and has remained so till this day. In the 19th century, the permanence of the atoms was enshrined in the principles of the conservation of matter and of energy. And the conservation principles say the total amount of matter and energy and angular momentum and electric charge are always the same. And the laws that govern them are always the same. And that's why science is supposed to be, any experiment is supposed to be repeatable anywhere at any time, because the laws of nature are the same at all times and in all places. This is the implicit philosophy underlying science. The universe is eternal, matter is eternal, the laws are eternal. And most physical and chemical scientists just take this for granted. When you look at the Mendeleev's periodic table of the elements in chemistry, you don't have any sense that this could have evolved. It's like a Platonic form of the elements and how they are, a kind of rational order of things. In the 17th century, the founding fathers of modern science, who were all Christians, believed that the universe, although essentially eternal, was actually created by God in time. God was like a great machine maker who created the laws of nature and the universe, pressed the start button, and then the whole universe went on like a great machine. That was what they thought. But by the end of the 18th century, with the growth of atheism, people wanted to get rid of this engineering God who started off the universe. There was a simple intellectual move by which you could do this. Just proclaim that the universe is eternal. Then you don't need a God to start it off. And that's what Laplace, the great French physicist, did. When Napoleon asked him what place God had in his scheme of things, he said, "Sir, I have no need of that hypothesis." Because they'd already got a stripped-down version of God as a kind of mathematical engineering creator who just started things off and then stood back. And by making the universe eternal, you could get rid of that kind of creator God. So the universe was eternal, the laws were eternal, the matter was eternal, the energy was eternal. When Einstein worked out the equations of his general theory of relativity, he found that they showed that the universe should either be expanding or contracting. He couldn't believe that was true because the universe must be eternal. So he introduced the cosmological constant into his equations to make sure it stayed the same. He later considered that his biggest mistake. But the universe, because it was later discovered, the universe is actually expanding. But that was a huge shock to Einstein because so deeply embedded in the thinking of physicists was this idea that everything's eternal, that it was a terrible shock for him to find that perhaps the universe isn't eternal, that it's unstable, it's expanding. Well, these are the ideas that have got totally built into our conception of reality through physics and chemistry, this notion of eternity from the Greeks. But the other great notion that's changed our thinking is the idea of evolution, and that is rooted in the thinking of the Jews. The Jews were the only ancient people who saw time in a linear, progressive way. All the other great civilizations and people of the ancient world saw time as eternal, moving in cycles. They saw eternal cycles. Whole universes came into being and passed away, and new ones appeared forever. So the eternity goes with the idea of cycles, and that goes with the idea of reincarnation. The ancient Greeks believed in those things. The Indians do to this day. The Buddhists, with their cosmology derived from the Indian one, implicitly do as well. So the idea of eternity is the standard default setting for most ancient civilizations. The Jews were different, though. They had a model of history that was modeled on a journey, And the prototypic journey was the journey out of bondage in Egypt, through the wilderness and to the promised land. This was a journey with a goal. And the goal originally was like the recreation of paradise, like rediscovering Eden, the promised land where there'd be peace, prosperity, brotherhood. It would be like rediscovering Eden at the end of history, paradise. So this is the kind of archetypal journey. It has a goal. Of course, when the actual Jews arrived in Palestine, the promised land, then as now, it turned out to be inhabited already by Palestinians. So instead of being a place of peace, prosperity, and brotherhood, it was a place of strife, conquest, bloodshed, internecines, squabbles, and feuds, and much of the Old Testament is taken up with these endless battles with the indigenous people of Palestine. So this ideal ending of history had to be projected into the future when the Messiah would come. And Christianity took over that cosmology, and then there was the idea of the second coming of the Messiah, the end of ordinary history. The idea that history was moving towards a goal or a culmination, preceded by a catastrophe, and then followed by some new order of time. Interestingly, in the 17th century, this essentially religious vision of history was secularized. The leading figure in this movement was Sir Francis Bacon, the Lord Chancellor of England. And Bacon had the idea that, yes, history would be transcended, we'd come to a whole new order of history, and that would come about through science and technology. Through conquest of nature, man would achieve a completely new relationship to the world, and human prosperity would be increased all over the world. He used very sexist language. He said, through putting nature on the rack, like witches were put on the rack, we can torture her and force her to yield up her secrets so that man can achieve dominion over her. Well, this has been the ideology underlying science and technology ever since. And his vision was that governments would sponsor a kind of scientific priesthood. Each country would have a kind of National Academy of Sciences as the officially approved scientific priesthood that would, under government control and direction, enable human beings to dominate and control nature, unleashing a new era of prosperity. Well, that vision of progress through science and technology has now conquered the world. No other ideology has ever conquered the world as that one has. Every government in the world is now into economic development through science and technology. It's an enormously successful vision. It's also at the root of our environmental crisis. It's produced all the damaging effects that we're living with today and fearing more of in the future. But this is an idea that had a huge influence. By the end of the 18th century, most European intellectuals and American intellectuals had adopted this philosophy. It was part of the Enlightenment cult of science and reason. And this led to the idea of human progress. But the rest of the world was thought to be static. The universe was eternal, species of animals and plants were fixed, only humans underwent this progress. It was essentially a religious idea in a secularized form. But by the middle of the 19th century, the idea of evolution was extended to all of life. In Charles Darwin's theory of evolution, 1859, the idea was that the whole of life evolves. All living beings have appeared, they've developed through time, through a vast evolutionary process. Darwin hardly ever used the word evolution, I think only twice in The Origin of Species, his most famous book. Instead, he used the word progress. And so he thought this was the progressive view of life being extended to all of nature. So now we had human beings progressing through science, technology, and social reform. We had now the whole of life progressing from humble beginnings through more complex life forms right up to the present day. But the rest of the universe was not progressing. Some philosophers, like Herbert Spencer in England, and Karl Marx and Friedrich Engels, said that progress must be a universal law, not just a biological law. But the physicists said, no, forget it, that's not what's happening. The universe is eternal, and not only is it not progressing, it's actually running down. by then they'd discovered the second law of thermodynamics that says that no, you can't have perpetual motion machines. So they had the idea the whole universe was eternal but gradually running out of steam, so that it would eventually freeze up in a universal heat death, but then remain frozen forever. So instead of the universe progressing, it wasn't. It was going downhill. And by the beginning of the 20th century, European intellectuals, more in Europe than America, were obsessed with the ultimate futility of life on Earth, human life, because all of evolution here was a flash in the pan in a universe doomed to extinction, a universe headed nowhere. A pessimistic kind of cosmic pessimism. By the 1920s and 30s, people were beginning to realize the universe was expanding. And in the 1960s, with the discovery of the cosmic microwave background radiation, the Big Bang theory became orthodox in physics. So since 1965, we've had the idea that the universe began very, very small and very hot, less than the size of a head of a pin to start with, and it's been expanding and cooling ever since. And as it expands and cools, new forms of matter come into being: atoms, molecules, stars, galaxies, planets. Everything in the universe has evolved. Nothing was there in the beginning at the Big Bang except this seething mass of undifferentiated heat and energy. So now we've got an entire universe that's evolutionary. And evolutionary cosmology has extended what was originally a Jewish religious vision through these progressive developments, through Christianity, through the early prophets of science and technology, through economic growth and development, through biological evolution, to the entire cosmos. Now, this is a huge change. It means that one of these worldviews, the evolutionary worldview, has now become completely predominant on a cosmic level. Where does that leave the eternal laws of nature and the eternity of matter and energy? Well, it leaves them sort of hanging in a void, because and if you ever meet any of these hard-nosed, aggressive materialist types, try out a question on them. Say, do you believe in the Big Bang? And they'll almost certainly say yes. And then you say, well, where were the laws of nature before the Big Bang? And you see, if they're eternal, they should have existed before the Big Bang, but where? There's no where for them to be. There's clearly a metaphysical or philosophical idea that is nothing to do with hard-nosed empirical science. And science is actually based on this implicit philosophy. In fact, modern science is based on an idea that my friend Terence McKenna used to say, that it's based on the idea of give us one free miracle and we'll explain the rest. And, and the one free miracle is the coming into being of the entire universe, all the matter and energy in the universe, and all the laws that govern it, from nothing in a single instant. So the Big Bang theory is radically evolutionary, and it raises the question that if everything else evolves, why can't the laws of nature evolve too? Why not? I mean, there's nothing, we can't prove they were all there in the form they are today at the moment of the Big Bang. Everything's evolutionary, why not the laws? And as soon as you ask that question, you realize that the concept of laws of nature is very anthropocentric. The idea of law is confined to human societies, and in fact to civilized societies. It projects onto the whole of nature a very human concept. As C.S. Lewis once said, to say that a stone falls to earth because it's obeying a law makes it a man and even a citizen. And so it's an extraordinary metaphor when you think about it. And if you do think about it, you realize that human laws do actually evolve. The laws of the US are not the same today as they were 100 years ago. So as a metaphor, it would imply evolving laws. But I think it's a very poor metaphor, and I think a much better one is habit. I think as the universe evolves, it develops new habits. Through repetition, habits become more and more repetitive, more and more predictable. And they become more and more as if they're governed by eternal laws. But with new phenomena, then you can actually see habits build up. This essentially is the idea of underlying morphic resonance. Morphic resonance is a theory that tries to explain how the universe can have developing habits. Habits imply memory. And how would this memory work? Well, the suggestion is that it depends on similarity. The more similar something is to something that's happened before, the more it will be influenced by it. And morphic resonance is the process whereby similar things in the past influence similar things today. I'm not proposing that there's a kind of cosmic memory bank where all this is stored. Memory is not a spatial phenomenon, it's a temporal phenomenon. It's to do with relationship in time. And I think morphic resonance depends on a kind of direct resonant effect of anything in the past on anything in the present that's sufficiently similar. By anything, I mean self-organizing systems like molecules, atoms, crystals, plants, animals, societies, planets, solar systems, galaxies. All of these organize themselves. They're radically different from machines, which are organized in accordance with human designs and put together in factories. In nature, most things organize themselves. In fact, everything organizes itself. Self-organizing natural systems have an inherent memory. And what I'm suggesting is that each species and each kind of thing has a kind of collective memory. Every individual contributes to it and draws upon it. We all draw upon a collective human memory, and in turn we all contribute to it. Every spider draws on a collective spider memory, including spinning webs, and contributes to it. Every migrating swallow depends on memory of the species, including previous migrations over the centuries. So this, in a nutshell, is the idea of morphic resonance. I've put it in simple, ordinary language because it's easy to get in ordinary language. Of course, it needs to be worked out in a more scientific form, and I'll say something about how it works through morphic fields in a moment. But first, I want to make the point it can be tested by experiment. And one of the easiest ways to see how this could happen is to look at crystals. This theory applies to the chemical realm as well as the biological. And in the realm of crystals, most people assume that crystallography is completely understood everywhere. It's fully understood by physicists how crystals form. Turns out that's not the case. Crystals form and physicists can find out what structure they have, but they can't predict it in advance. Because as soon as you get into any degree of complexity in chemistry, the way the atoms and the molecules could line up to form the crystal, it turns out there's hundreds of ways they could do it, and they only do it in one way, sometimes in different ways. Then you get polymorphic crystals, but usually in just one way. So if you make a new chemical that's never existed before, and chemists do this every year, then what form will its crystals take? The conventional view is that this should, in principle, be predictable on the basis of the eternal laws of nature, the laws of quantum mechanics, electromagnetism, thermodynamics, etc. In practice, no one can actually do these calculations. They're too complex. So it turns out that we don't know that that's true or not. It's just an assumption. But according to morphic resonance, the first time the crystal forms, there won't be any previous crystals of that kind. There won't be an existing form that will force it one way rather than another. You just have to wait until the crystals spontaneously form. Sometimes it takes years for a new compound to crystallize. Once it's happened, according to morphic resonance, it should be easier to do it anywhere in the world because it's happened once in one place. The second time it happens, it'll be easier because of the first time. The third time, it'll be easier still because of the first and second times. They'll have a resonant influence on the third lot. The fourth lot will have influences from the first three lots of crystals. There'll be an accumulative memory, and it should get easier and easier to make crystals of that kind as time goes on, as other people make them in different parts of the world. Is this true? Well, it turns out that it is. It's well known to chemists that new compounds are very hard to crystallize. As time goes on, they get easier. But they don't explain this in terms of morphic resonance. They explain it in terms of anecdotes. And the favored anecdote, believe it or not, among chemists is that this happens because fragments of previous crystals, which are known to be able to nucleate crystallization, make it happen more easily, that fragments of previous crystals are carried from laboratory to laboratory around the world on the beards of migrant chemists. And if there haven't been any bearded chemists visiting, it's assumed that they've been wafted around as invisible dust particles in the atmosphere. Now, these theories are testable, but they've never been tested. Chemists take it for granted that the phenomenon can be explained by stories of this kind, because they're so convinced that the laws of nature are eternal, they don't see there could be any other explanation, like morphic resonance. I'm saying that it should get easier to crystallize these compounds as time goes on, even if you exclude migrant chemists and filter dust from the atmosphere, it should still be easier. And that's a test. It turns out there's another test. If the crystal, the morphic field of the crystal gets stronger through morphic resonance, it should be harder as time goes on to break up the crystals. In other words, you'd need a higher temperature to make them break up. In other words, their melting point should increase. Now, anyone who's studied chemistry will know that melting points are supposed to be constant. They're a feature of a given chemical. You look them up in books in science libraries called Handbooks of Physical Constants. It says on the cover, constant, so you expect them to be constant. So could melting points actually increase? Well, this is a very, very heretical thought, and I was trained as a chemist to start with, and it certainly took me a long, long time to be able to challenge the belief in the fixity of melting points. I then decided to look at the history of melting points. I'm perhaps the first person to have done that, because it's assumed they're constant. No one looks at their history. I first started by asking chemists if they'd noticed that melting points went up. And I felt a bit shy about asking chemists something so heretical. So the first chemist I asked was Sasha Shulgin, the designer of designer drugs. And I thought, he's a psychedelic-taking designer, drug designer. At least I can ask him this question. So I did. Far from reacting with shock and horror, he said, well, sure, when you make new compounds, you often find the melting point goes up over time. So I said, well, how do you explain that, Sasha? And he said, well, he wasn't thinking of morphic resonance, he just gave a kind of conventional chemical explanation. He said, well, as time goes on, you get better at making it, they're purer samples, and purer samples have higher melting points, because impurities lower the melting point. Well, that's true. And actually, since then, I found every chemist I've discussed this with has come up with the same answer. Well, if melting points go up, it's just because you're getting purer samples. And I said, well, how do you know they're purer? And they said, well, they must be purer because they've got higher melting points. So I decided to look at a range of compounds that have been around in nature for millions of years in crystalline form. You wouldn't expect to see a change after millions of years, billions and billions and billions of crystals. Then you'd hardly notice any difference today. They probably reach some kind of asymptotic limit and stabilize. But new compounds should show increases in melting point. Ones that have just been crystallized in recent times. Well, here is an example of melting points of amino acids. And on the left we have amino acids that do crystallize in nature. Asparagine, cysteine, and glutamine all occur in nature. And these graphs show that the melting points have hardly changed. 1935, 1980, 1996. These melting points are indeed constant, as you'd expect if melting points have morphic resonance effect in them, and these have been around in nature for a long time. On the other side, we see amino acids that were first isolated and crystallized in the 20th century. L-leucine, for example, there it is in 1930, and by 1958, its melting point had gone up about 25 degrees centigrade. Here we have L-tryptophan in the middle. Its melting point in 1901 was 252. It's now 289. So we see these big increases in melting points, not fractions of a degree, but tens of degrees. This is one set of comparisons. Another set here are compounds that occur in nature and then chemical derivatives only made in the recent century or so. There at the top is L-cocaine, which occurs in coca leaves, and there's very little change. Cocaine hydrochloride, the cocaine of commerce, made by extracting coca leaves with hydrochloric acid, has shown an increase in melting point of about 14 degrees since 1915. Penicillic acid is in excretions of molds. Penicillamine, made in the chemical industry as a derivative of it, has gone up from 192 to about 213. Here's salicin that occurs in willow bark. It hasn't changed. Here's aspirin, acetyl salicylic acid, first invented in the 19th century, used obviously as a very common kind of drug, that's gone up considerably. So here are some actual data from the archives of chemistry that suggest this is going on. It should be possible to do simple experiments in chemistry to find out if this is in fact applying more widely. But this preliminary data suggests something really is happening. In biology, morphic resonance would predict that if you get organisms to develop in an abnormal way, the more often they do it, the easier it should get. Here's a normal fruit fly, which is a favorite organism of geneticists, an unfavorite organism of many householders, but unfortunately this became a real personal clash for me when I proposed doing a whole series of fruit fly experiments at home. I had a terrible problem with my wife, who banned fruit flies in our house. So that's the regular fruit fly. Here's a mutant one where the balancing organs, the Holters, have been turned into an extra pair of wings. So these are unusual fruit flies. Now it turns out you can find these with mutations, but also if you treat the eggs of fruit flies with ether 3 hours after they're laid, you can produce the same abnormality without genetic change, a bit like thalidomide babies. Chemical change in the environment can lead to an abnormal form. If you do this over generations, the first generation, only about 2% are abnormal. And if you keep doing it, the percentage goes up and up and up till you're getting about 30% abnormal. This has nothing to do with mutations. It shows that by acquiring a characteristic by an environmental influence, it becomes more likely to happen again. You stop giving them the ether, and the abnormal ones go on being produced in a declining rate over many generations. This is a fascinating finding. It goes against the findings of regular genetics. It's not what you'd expect. But even more surprising is that in this particular experiment, after the 10 generations had been going on, a fresh batch of flies were treated with ether. In the first generation, instead of 2% being abnormal, it was 10%. The second generation, instead of 5%, it was 20%. So it was getting easier and easier for this abnormality to appear. This is what you'd expect with morphic resonance. The same applies to behavior. If rats learn a new trick in Seattle, it should get easier for rats all around the world to learn the same trick. Just by morphic resonance. They don't need to know about the rats in Seattle. They don't need to squeak to them over the telephone. There doesn't need to be any kind of normal communication. There's a kind of collective memory building up. It turns out that people have actually observed this effect. At experiments carried out at Harvard on rats, it was found that rats could be trained to escape from a water maze. The first generation found it very hard to escape. It took hundreds of trials before they discovered. The next generation, it got easier and easier. They made fewer and fewer errors. This suggested that they could inherit something their ancestors had learned. Well, this is one of the big heresies in biology, Lamarckian inheritance, the inheritance of acquired characters. Not supposed to happen. In fact, it does. And in these Harvard experiments, they were very controversial. And people said, well, obviously it must be genetic selection, because in each generation they must have taken the parents that learned smartest, that learned quickest as the generation parents of the next generation. So there must have been unconscious genetic selection for smarter rats. So the person who was doing this, William McDougall, professor at Harvard, said, okay, we'll do it again, but this time we'll select as the parents of the next generation the most stupid rats. So they should make more and more errors in each generation, according to that theory. In fact, these are the number of errors, and as you see, the number of errors fell dramatically over time with generations of stupid rats. They should have been going the other way. In fact, the stupid rats were finding it easier and easier to learn this, to escape from this maze. It was so controversial, people tried to repeat it, and they did so in Scotland and in Australia. The Scottish and Australian rats took up more or less where the Harvard rats had left off. And they showed the same effect. But the Australians got another batch of rats, and in each generation tested rats whose parents had never been exposed to the water maze. They were getting better too. So it couldn't have been a genetic change. So everyone heaved a sigh of relief and said, oh, it's nothing to do with modifying the genes. Standard genetic theory is fine. But what they didn't explain was the effect itself. This was left completely unexplained because it didn't fit in. And these data are lying there in the archives and fit perfectly with the idea of morphic resonance. Now, the idea of morphic resonance should also apply to human beings. It should be getting easier to learn things that others have already learned. It should be getting easier to learn to program computers, do windsurfing, skateboarding, any of these new skills that people learn. Most of them are getting easier to do, but of course it could be because of TVs, instructional videos, better designs, new training methods, and so forth. So to test morphic resonance, you need to do specially designed experiments. One experiment that I conducted in Europe in the 1990s is in the 1980s even, one of the first experiments involved puzzle pictures. This is a puzzle picture, as used in this experiment. Now, if you look at it, you may not actually see very clearly a particular image that's hidden within it. If you just look at it for a little while, see if you can see it. I'm going to show you the answer in a moment, and then I'm going to ask you how many of you actually saw that. I know it's going to be a small minority. Now, okay, there's the picture. Here's the answer. There's the picture again. Yeah. Now, how many people got that first time round? Thank you. It's about, I should guess, about 5%. Well, what we did, we had two pictures like this. We showed one of them on British television to 8 million people and melted the puzzle picture into the answer and back again, so 8 million people got it. Meanwhile, we tested people in Germany who couldn't see British television. And with the two puzzle pictures, the control and the test one, we found that people in Germany found it easier to recognize the test one after millions had seen it in Britain, but not the other one. So this is one of the various experiments that have been done directly to test morphic resonance. Another kind of experiment you've just done. That involves words. Each word has a kind of morphic field. When you read a word, you have a kind of gestalt, a pattern, a form. You don't spell out every word, k-a-t, cat. You just see the word, you get it instantly. That means there's a kind of collective memory for reading words, for real words. But not for false words. If you have the same letters, T-C-A, for example, it doesn't make a word and you don't instantly get it. It's been found by a number of investigators that if you compare people's ability to remember or recognize real words compared with false words, most people, without knowing they're doing it, can recognize the real words better. You've just done an experiment that involved 8 Greek words. three-letter words. 4 of those three-letter words that you saw were real Greek words that have been read by Greeks for millennia. The other 4 were anagrams of real words that aren't real words. And the question is, will you have remembered the false words less well than the real words? And we've done tests that show that people can't consciously tell the difference between the real and the false words, people who don't know Greek. But so far, I've done this experiment 8 times. 7 times, it's shown a clear, significant positive result. I don't know the results of this. My assistant's going to have many happy hours of marking your answers, and we'll find out the results probably in a week or two's time. But so far, this kind of experiment is giving very encouraging results, that people have an unconscious ability to read languages that they can't read normally, an unconscious ability to recognize real words because of morphic resonance from those who've done them before. One of the very few areas where standard tests have been done over many years, where you can look to see if there's a change in time, is IQ tests. Similar tests have been done now for decades. According to morphic resonance, the scores on IQ tests should be going up, not because people are getting smarter, but because the tests are getting easier. And so I predicted this in the 1980s, but I couldn't get hold of the data from IQ tests. And I was delighted to find that a scientist called James Flynn did actually do this. And he found that in the US, there's been a very dramatic increase in average IQ test scores since the 1910s, right up to the present day, showing a really significant increase. This has been mirrored in many other countries too. IQ tests are getting easier to do, but people are not getting smarter by any other criterion. This is now called the Flynn effect, and it really baffles psychologists. Flynn himself says he's baffled by it. People have tried to explain it in terms of better nutrition, more brain growth, more TV. They've tried all sorts of things, more exposure to tests. None of these explanations really explain it convincingly, and it remains an unsolved mystery. It's just what you'd expect on the basis of morphic resonance. A couple of years ago, my older son, who was then 16, was doing the national examinations in Britain, which we call GCSE, General Certificate of Secondary Education. Everyone in the country has to do the same exams, and of course they do them at the same time. Before the exams, he came to me one day and said, very excited, and he said, I and my friends have just thought of a way of getting better scores at GCSE without any extra effort. And I said, well, that sounds a good idea. What's it based on? He said, morphic resonance. And so I said, well, how did you work that out? And he said, well, one of my friends had been reading your book. Note, he hadn't, but one of his friends. And he said, and we were discussing it, we came to the conclusion that if in the physics and maths tests, for example, where there are 15 questions, if we do questions 14 and 15 first, and then go back to question 1, 2, 3, 4, we'll be about 10 minutes behind everyone else in Britain for all those other questions. We'll get a boost by morphic resonance. So I said, well, that's a good idea. And I said, well, there must have been some skeptics in your group of friends. And he said, yes, somebody said, what if morphic resonance doesn't really happen? And so we concluded that if it doesn't really happen, we wouldn't lose anything, but if it does, we'd gain something. So they actually did it. They all did very well, but they're probably smart in the first place. But it turns out this is a very good way of testing it. It also turned out an old friend of mine from Cambridge was in charge of science examinations in Oxford and Cambridge Examination Board. I tried to persuade him to alter the order of the questions for small subsamples of the population to test morphic resonance, to turn our national science exams into a vast morphic resonance experiment. He was intrigued by the idea, but in the end felt he couldn't risk his career on something so controversial. It turns out that in Holland, all exams are done with people at alternate desks have papers in questions in a different order, A and B forms of the questions. So one lot do questions 1 to 8 and then 9 to 16. For the other lot, 9 to 16 are called 1 to 8, and then 1 to 8 are called 9 to 16. So people at adjacent desks can't copy from each other. That means in Holland they've already got a huge database of exam results that could be used to test this theory. And a colleague of mine at Amsterdam University, Dick Bierman, has already looked at some of their university exam results and found that in 7 out of 8 papers, morphic resonance, the morphic resonance prediction has come true. There were higher hit rates, higher success rates when people did questions later than earlier. They're now, at this moment, examining dozens more papers from results from Dutch examination papers to see if this effect shows up. This also applies to crosswords. It should be easier to do the New York Times crossword from tomorrow, than it was today. And some tests have been done to test this with positive results. So this is a very testable theory. It leads to the idea of collective memory, and the idea of a collective human memory is, of course, not a new one. It's been around for a very long time. Jung, the psychologist, suggested we all tap into a collective memory. And I'm saying the same thing, only I'm saying it's just part of the way the whole of nature is, the way all species are, not just the way that humans are. There's one final implication that's particularly mind-boggling. Well, there's many implications. I only have time to mention one of them. And that is this. If morphic resonance depends on similarity, and we have a kind of collective memory from past members of the human species, then the first point is we'll have a more specific memory from people who are more like us, members of our own families, for example, and our ancestors. So there'll be a more specific memory from our ancestors. But then if you ask, well, who in the past is most similar to me? The answer is me. Each of us is more similar to ourselves in the past than to anybody else. That means that the most specific morphic resonance acting on any one of us is going to be from our own past. This self-resonance means that we can resonate with ourselves in the past, and our memories can be transferred by morphic resonance from our own past. I'm suggesting that memories are not stored in the brain, as commonly assumed, but rather occur through self-resonance with our own pasts. Our brains are more like TV receivers than video recorders. We tune into our pasts when we recover memories, but they're not stored in the meantime in the brain. Because most scientists take the materialist theory of mind for granted, they assume that memory must be in the brain. Where else could it be? It's simply taken for granted. It's one of those paradigms, an unchallenged assumption. It turns out, despite more than 100 years of intensive research and the expenditure of billions of dollars on trying to find memory traces in the brain, people have been extremely unsuccessful. People have tried and tried again, but failed and failed again to find memories in the brain. Every kind of theory has been tried. DNA, RNA, protein modification, synaptic modification, phosphorylation of synaptic proteins, and so on. They've all drawn a blank in one way or another. And I think that's because the memories aren't there. You can no more find memories in the brain than you can find memories in your TV set of what programs you watched yesterday. It's simply not the way it works. Well, this is obviously a radical and, of course, controversial interpretation of memory, but it's a natural extension of the morphic resonance idea. And wherever one extends this idea, it turns up predictions that seem to fit the facts, often in variance to conventional scientific theories. But the memory theory of the morphic resonance memory theory does work, I think, much better than the conventional one. Of course, you can get memory loss through brain damage or through brain degeneration, as in Alzheimer's disease. But that doesn't prove it's stored there. If I came and clipped out random bits of your TV set, I could affect the way it receives pictures or produces sounds, but it wouldn't prove all those sounds and pictures are stored inside the TV set. It would just prove that those bits were important for the reception or tuning, and I think that's true of the brain as well. Well, this gives you a brief overview of the morphic resonance idea. These notions were first put forward in my book, A New Science of Life, much more fully developed in the presence of the past. And I've gone on doing research on this in one way or another ever since. And it has many, many implications in many areas. So this is just a very brief view of some of the main features of morphic resonance. I haven't yet talked about morphic fields and how this resonance is expressed. But before I do that, I think it's time for us to take a short break. And then I'm going to come back to the fields, and then there'll be time for questions and discussion after that. I'm trying to cover a great deal of material this morning, and that means that there's less time for discussion. I know some people here have a lot of questions, and I wish we had more time or more opportunity, but it's a kind of trade-off. And so I'm going to try and tell you something about morphic fields and the extended mind and some of the experiments I've been doing, and I hope we'll have time for some questions and comments at the end. So the idea of morphic fields is that self-organizing systems have fields which organize them, give them their shape or form, and every self-organizing system has a vibratory pattern of activity. Every atom, every molecule, every crystal, every cell, every human body all have rhythmic patterns of activity. And it's those rhythmic patterns of activity that resonate across space and time. The idea of morphic fields grows out of the idea of morphogenetic fields in biology. I started as a developmental biologist, and the idea of these fields was first put forward in the 1920s to try and explain how developing organisms develop. Genes alone and chemicals alone are not enough. Your arm and your leg have exactly the same genes in them, exactly the same chemicals, but they have different shapes. There's something about developing organisms that acts like a kind of architect's plan, a building plan for the organ. And as organs grow, they take up particular shapes. And the idea is that morphogenetic fields, fields concerned with the coming into being of form, morphogenesis, are what shape them. This idea has the additional attraction that fields are inherently holistic. Fields can only come as wholes. You can't get a bit of a field. You can't have a bit of a gravitational field or a bit of a magnetic field. And if you think about it, this holistic property is a key feature of fields of all kinds. If you have a magnet, a bar magnet, and you cut off the North Pole, you don't get an isolated North Pole. What you get is two magnets, each with a North and a South Pole. They instantly regenerate a whole magnetic field. And this was one of the analogies in the idea of morphogenetic fields right from the beginning. And it helps to explain how living organisms have the ability to heal themselves after damage. These fields are integrative and healing in their effects. In the most dramatic cases, they underlie regeneration. You see, this is very different from machines. If you have a machine, the machine's put together with different parts that are designed by an external mind, a human mind, and they don't have a holistic quality. If you cut a machine in half, all you get is a broken machine. But if you cut certain organisms in half, each half can grow to form a new organism. And this regenerative capacity is very strong in many plants and lower animals. If you cut a willow tree into lots of little bits, each bit can become a new willow tree with shoots and roots. Just like if you cut a magnet into little bits, each little bit is a complete magnet with a complete field. If you cut a flatworm into pieces, each piece of the flatworm can grow back into a new worm. So here at the top, you've got, here's the head, and the head can grow the whole new body. And here are different parts of the body that can regenerate the entire flatworm. This is because each part of the worm has a complete field associated with it, just as a magnet has a complete magnetic field associated with it. I think these morphogenetic fields provide an integrating way of understanding healing processes in general. This is a dragonfly embryo within the egg, and normally the lower part of the egg would form the lower part of the embryo. In this case, the egg was tied off and this part was killed. The lower part of the egg now forms a small but complete embryo, showing the capacity of the system to organize itself as a whole. This is an experiment involving the removal of the lens from the eye of a newt. So here's a hole where the lens used to be, surgically removed. And what happens is the newt regenerates a new lens from the edge of the iris. Normally, the lens forms from the folding in of external skin, not from the edge of the iris. But somehow, the eye has a capacity to form its whole normal form by an unusual method through regeneration from the iris. And again, the presence of an organizing field would help to explain this, whereas a purely mechanistic explanation in terms of just chemicals and genes just couldn't possibly begin to explain this kind of thing. I'm suggesting that morphic fields depend on morphic resonance. They have a kind of memory from many members of the species in the past. Since all the members of the species are slightly different, it means the fields are probability structures. And here's an analogy. These are average scientists from the John Innes Institute in Norwich, England, made by superimposing photos of 30 female and 45 male scientists. And what you see is a kind of probabilistic outline of the average scientist's face. And I think if you could see morphogenetic fields, they'd be a bit like that, sort of blurred at the edges. They work probabilistically like quantum fields. And morphic fields are arranged in nested hierarchies. These could be subatomic particles in atoms, atoms in molecules, molecules in crystals, or they could be organelles in cells, in tissues, in organs, in organisms, in societies of organisms. Everywhere in nature we find this nested hierarchy, this ordering of parts within wholes, and the parts are themselves wholes at lower levels. And at each level the whole is more than the sum of the parts, because, I would suggest, it has a morphic field, which is what gives it its wholeness. So, that's a very brief overview of some of the ideas about morphic fields. And what I'm going to do now is take a huge jump, because we're covering virtually everything today. I mean, Bruce and I, between us, are going to cover all the mysteries of the universe. We're not going to solve them all, but we're going to touch on them here and there. So I'm moving now on to the mind and the nature of the mind. I think that the organization of the brain depends on fields. Sorry, I just turn this off. Sorry, hang on. I've just got to get rid of this from the screen. Do you know how I do that, Bruce? It's Bruce's computer, so...
Take up the mirroring. Take up this.
Oh, yes.
And
Oh, yes, I thought I'd done that. Okay, thanks. Good, that will be next. Okay, the mind. I think that the brain is organized by morphic fields which influence probabilistic processes. Morphogenetic fields shape the body. Then there's behavioral or motor fields which shape the activity of the nervous system by imposing patterns on what would otherwise be chaotic activities. Then there are social fields that organize social groups like flocks of birds and schools of fish and termite colonies. All of these are called morphic fields. All of them have morphic resonance. Morphogenetic fields are specifically those concerned with the development of form and maintenance of bodies. So they're like a species of the bigger genus morphic field. Now, when it comes to the nature of the mind, what I'm going to suggest now is that our minds depend on fields, and that the fields of our minds extend far beyond our brains. The standard view within science is that the mind is the brain. Mental activity is brain activity. This is the materialist philosophy of mind. And this is the taken for granted view in medical schools and in universities all over the world. It's never been proved. It doesn't make sense to most people, but nevertheless it's taken for granted within scientific institutions. I'm suggesting instead that our minds extend out beyond our brains into the world around us through fields. We're all used to the idea that fields extend beyond material objects. Magnetic fields extend beyond magnets. The Earth's gravitational field extends beyond the Earth to keep the Moon in orbit, for example. And the field of a cell phone extends beyond the cell phone. All that's standard modern technology, which is nearly all field-based. I'm suggesting minds are like that too, that the mind isn't just inside the head, but stretches out beyond it. And as soon as we get the idea that our minds can be extended beyond the brain, a lot of otherwise puzzling phenomena make sense. So I'm going to consider first vision as an example of this. What happens when you see something? Like you're seeing me now, and what's going on while that happens? Well, part of it's well known. Light's reflected from me, reaches your eyes through the electromagnetic field, small inverted images on your retinas, changes in the cone cells, impulses up the optic nerves, and activity in various parts of the brain. So far, so good. But all it gets us is activity in various parts of the brain. That's rather different from vision. The first problem is that science can't explain consciousness. There's no explanation in physics and chemistry for consciousness. And this is now called the hard problem, because no one knows how to solve the problem of consciousness from regular mechanistic science. But the second problem is less widely discussed, and that is that all this is meant to happen in your brain. So when you see me standing here now, what's happening is that changes are happening in your brain that mysteriously, in a way that no one can understand or explain properly, become conscious. But it's all meant to be inside your head. You have some kind of virtual reality display inside your brain that has an image of me in it, and this room and everybody else here, inside your head. Now, I'm guessing it doesn't actually feel as if it's all inside your head. And the theory I'm putting forward is so simple, it's hard to grasp. And that is that your image of me isn't located inside your head, it's located right here, outside your head, and it's in your mind, but it's not inside your brain. So I'm suggesting vision involves a two-way process, the inward movement of light and the outward projection of images. That everything you're seeing around you is projected out to where it is. Occasionally this goes wrong, then you have hallucinations or illusions. But usually it works well enough, and if it didn't work well, if you were projecting images to the wrong place, you wouldn't have got here this morning. You just need to project things accurately to the right place to survive and to move around. So I'm suggesting that vision involves a two-way process, inward movement of light, outward projection of images in mental fields. These are a kind of morphic field through which we're projecting out the whole world. If you look at the sky, you're projecting it out up to the sky. If you look at stars, you're literally projecting your mind out over astronomical distances. The conventional view is that it's all in the head. And the conventional view says that when you look at the sky you're seeing is inside your head. And as a recent paper in a leading scientific journal put it, it asked the question, is your skull beyond the sky? Because if it's in your head what you're seeing, it should be. The skull should be beyond the sky. The answer they gave was yes, it is, because it's all inside the brain. It's counterintuitive, and in fact I think it's wrong, but that's the official view. I'm suggesting it really, the projected images are out there. That means you might be able to affect things by looking at them. It means you might be able to affect other people by looking at them. Of course, if they know you're looking at them, this is ordinary psychology. But if you look at someone from behind, maybe you can affect them just by staring at them from behind. Does that happen? Well, the answer, according to surveys, is that most people have had that experience. How many people here have felt they were being stared at from behind? Well, that's almost everybody. Surveys show that it's over 90% in a normal population. There is a slight sex difference. More women than men have experienced being stared at, and more men than women have experienced staring at others and making them turn around. Well, most of us are mere amateurs, but through a research assistant of mine, I interviewed security personnel, private detectives, the drug squad at Heathrow, the police training college in England, sheriffs involved in surveillance work in the United States, and so on, store detectives and others. They all know about this. They take it for granted that if you're looking at someone, they're likely to turn around. These are people who spend all day watching other people. They're experts. In the martial arts, it's taken for granted. You can train your sensitivity to being looked at from behind. Very useful if someone's creeping up to attack you from behind. In the British Special Forces, the SAS, when people are trained how to creep up behind someone to stab them in the back, they're trained not to stare at the guy's back because he's likely to turn around and shoot you first. So these things are well known in the security and the military areas and in the martial arts. What does science have to say about this? The answer is practically nothing. Between 1895 and 1985, there's a total of 4 published papers in the whole scientific literature on this feeling of being stared at. The first 2 were written by skeptics, simply dismissing it as an illusion, as a common illusion. Well, it's found all over the world. Adults have it, children have it. The reason I think it's so widespread is because it really happens, because most people have experienced it. I've done many experiments that are designed to test this. The simplest ones involve people working in pairs. One's blindfolded. The other one either looks or doesn't look in a random sequence. You have to guess if you're being looked at. Most people are right above chance levels. Now, hundreds of thousands of these tests have been done. Many of them have been done in schools, because children are more sensitive than adults. And school teachers are actually quite open to doing this in schools. Most of them are well aware of the power of the gaze. It's part of their stock in trade. And so these experiments on the sense of being stared at have been done on a mass scale now. You can find a summary of these results in my book, The Sense of Being Stared At, also on my website, The Technical Papers. It's also been done in a science museum in Amsterdam. Over 20,000 people have done this experiment already, and the results are overwhelmingly significantly positive. It seems to happen, even through windows, even through one-way mirrors, even through closed-circuit television. There have been experiments on CCTV showing people can tell when they're being stared at. So it does seem to happen. Therefore, there's something about looking at people that seems to be able to affect them, and that shouldn't happen if it's all inside the brain. Yet the evidence is overwhelmingly in favor of it being real. And that is one way, I think, in which our minds project out into the environment. They connect us with what we're looking at, in accordance with our attention. The word attention comes from the Latin root ad tendere, to stretch towards. Our minds stretch towards things that we pay attention to. Well, animals seem to be sensitive as well. Many people have found that they can attract the attention of animals by staring at them. Some people have found it works the other way around. And I think this has an evolutionary origin. Prey animals that could detect when predators are looking at them would probably survive better than ones that couldn't detect it. So therefore I think that this is basically a predator-prey thing that's probably been around for millions of years. Animals have this sensitivity. And animals are most sensitive, most vulnerable when they're asleep. You would expect sleeping animals also to have this sensitivity, and indeed they seem to. Many people have found that they can wake sleeping animals by looking at them. Some people have found that dogs or cats can wake them by looking at them. And this is one of the areas I'm doing research on at the moment under the slogan, "Don't let sleeping dogs lie." So if you have a dog at home and it sleeps a lot, or a cat, try waking it by staring at it. See if it works. Some cats and dogs are more sensitive than others. But a lot of people have found that babies can be woken by staring at them. A lot of parents avoid staring at their sleeping babies because they don't want to wake them up. So this seems to be a real phenomenon, and it suggests that our minds are indeed extended beyond our brains through fields. That's my interpretation of this phenomenon. It doesn't make sense from the conventional point of view that people could tell or animals could tell when they're being stared at, which is why the subject has been completely filtered out of psychology courses. You won't find a mention of this in psychology textbooks. You won't find it discussed in psychology courses. Psychology lecturers have been trained to dismiss it as a mere coincidence or an illusion. It just doesn't fit in. It's one of those anomalies that doesn't fit in. And it's one of those, what I call mysteries of everyday life, that tells us that reality is very different from the way the current scientific model portrays it. The first and most profound mystery, of course, is the consciousness itself and the fact that you see things outside yourself. And I'm saying that that itself is a mystery. The fact you can see anything at all, and you can see things outside yourself, that depends on the mind being stretched out beyond the brain. Well, the way that morphic fields connect animals together in groups also has many implications. I'm suggesting that morphic fields link together animals in groups, that the whole group of animals, like a flock of birds, is part of a field phenomenon. When they change direction, they all change at almost the same time. It's as if it's a field effect. The best computer models are field models for this. The same is true of schools of fish. And I think herds of animals, packs of wolves, and so on, all work in accordance with morphic fields coordinating the group as a whole. Human families, human social groups, football teams, I think all have morphic fields as well. The group has a field. Because these fields link together members of the group, and because through time there are memories of the past interactions, there's a kind of morphic resonance built into these fields, a kind of memory of the group. The bonds that build up, I think, are real, not just metaphorical. If you have wolves that go hunting, leaving the young in the den, the cubs in the den, they range over hundreds of miles as they hunt. The field of the group stretches as they go apart. It doesn't break. They remain connected at a distance. So a change in one can affect the other. That, I think, is the basis for telepathy, which is, I think, a connection between members of animal groups separated at a distance, or indeed when they're close together. Telepathy literally means distant feeling, distant, pathy, feeling, as in sympathy or empathy. And what I'm suggesting is it's normal, not paranormal, natural, not supernatural, just part of animal communication, the way that social groups are organized in the animal world. There's quite a lot of evidence for wild animals being telepathic with each other. The best book on this has recently been reissued. It's called How Animals Talk, by William Long, an American naturalist. It was first published in 1919. It's recently been reprinted. And it's a wonderful study of animal telepathy in the wild by a very observant naturalist. But telepathy as a whole has been ignored by science because it's one of those taboo topics. It doesn't fit into the materialist theory of the mind. So most scientists pretend it doesn't happen. And most educated people feel that they have to pretend it doesn't happen in order to retain their credibility as an educated person. This has become a kind of social phenomenon. It's a social taboo. One of the definitions of being an educated person is that you're not gullible, taken in by credulity and superstition. And telepathy has been classified as credulity and superstition. It's now opposed by well-organized and well-funded vigilante groups like SciCop, the Committee for the Scientific Investigation of Claims of the Paranormal. These skeptic organizations try to prevent the media reporting positively on investigations in telepathy because it's such a deep taboo. Most scientists don't work on it, not because they're not interested, because they can't get funding. And so it's one of those areas that's kept at the margins of science. I'm suggesting all this taboo stuff is totally unnecessary. It's a regular phenomenon. It can be studied scientifically, and it helps us understand more about the nature of minds and social organization. And part of my work in recent years has been looking at experimental investigations of telepathy in animals and people. Well, one of the things that many people have noticed is that their pets seem to pick up their intentions. And because pets are the animals we know best, and because they form bonds with their human owners, this provides a very fertile field for research. I discovered that there's also a taboo about investigating pets. Very little research has been done with pet animals, which is a shame because they're the animals we really do have the most observations on, because people live with them and see them night and day. So I started investigating this and found that lots of people have stories about their pets, picking up their thoughts or intentions. But this had never been scientifically studied before. So to do this research, I launched an appeal for information. I asked people to write and tell me about their experiences with their pets. And when I first did this in Britain, I was overwhelmed by the response. I just didn't know how to cope with it. I had hundreds and hundreds of letters. I ended up with my study ankle deep in letters, and I didn't know how to classify them. And luckily, some friends helped me set up a computer database. And this is the perfect way of classifying this information. Now most of it comes in by email, so it's easy to put on the database. I have more than 5,000 case histories in many different categories. These reveal a kind of natural history of these otherwise unexplained forms of animal behavior. Some scientists dismiss these stories by saying they're just anecdotes. And I heard this so often, I looked up the word anecdote to find out what it really means. It comes from Greek root meaning an ekdotos. An means not, ekdotos means published. An anecdote is an unpublished story. As soon as it's published, as many of them are in medical journals, it's promoted to the rank of case history. And so case histories are basically published anecdotes. And as far as I'm concerned, the plural of anecdote is data. If you have lots and lots of stories from different people about the same kind of phenomenon, it shows something's really happening, or at least people believe something's really happening. I can't go through all the many fascinating cases of animal behavior I've encountered so far, but let me give you just one or two examples. We had hundreds of letters from people about their cats, saying that the cat seemed to be able to read their intention to take the cat to the vet, and the cat would disappear. After this happened several times, people got, it was annoying for them to find the cat disappearing, so people avoid trying to think of the vet. Some desperately say, don't think of the vet, don't think of the vet. The cat still disappears. And they try to avoid letting the cat see the carrying basket and so forth. Some people, driven to despair by this happening over and over again, ring the vet from work so the cat can't overhear the conversation. And then they swing by home on the way from work to pick up the cat to take it to the vet's office. Still not there. We heard so many of these stories that the next stage in this research, first natural history, collecting stories, second surveys. So we did a survey to find out how common it was. We called all 65 veterinary clinics listed in the North London Yellow Pages. We asked them if they had a problem with people missing appointments with cats. 64 out of 65 said, yes, it happens all the time, because people say the cat's disappeared. And the one remaining one said it happened so often they'd given up an appointment system for cats. People just have to... People just have to turn up with their animals. One of the commonest kinds of report we got was about dogs and cats knowing when their owners are coming home, going and waiting at a door or a window before the absent person returns. Now, no one thinks this is strange if it's at a routine time. It could just be a biological clock. No one thinks it's strange if it's only a minute or two before. It could be hearing footsteps in the street. But in many cases, it happens when people come home at non-routine times, and also when more than 10 minutes in advance, when they're still several miles away. What's going on? Well, I discussed this with a skeptical friend who said to me, when I told him about it, he didn't deny the phenomenon. He said, oh, my dog used to do that. My mother always knew when I was coming home, even half an hour in advance. And I said, well, how do you explain that? I said, it couldn't possibly have been the dog hearing your car engine from many miles away. He said, oh, on the contrary, it just shows what sharp hearing they've got. So that was what led to the idea of an experiment. The experiment is go at least 5 miles away from home, come home at a random time in a taxi or other unfamiliar vehicle. We've now done hundreds of these tests. We videotape the place the dog waits. We know exactly where it is all through the period when the person's on the way out and on the way home. And what we find is that over and over again, the dog goes and starts waiting when the person's on the way home, or in the most sensitive dogs, when they form the intention to go home, before they've even got into the taxi. It seems to be responding to their thoughts, their intentions, at a distance. There's now a lot of evidence for this. Cats do it too, less cats than dogs, not necessarily because cats are less sensitive, some of them just are less interested. And a number of other animals do it. One case I heard of on Whidbey Island near here was a hand-raised lamb that had been brought up by bottle feeding. That did it when its owner was coming home. A few rabbits and guinea pigs do it, ferrets, parrots, parakeets. It's not just dogs and cats, but it is animals that we form bonds with. It has to be animals with which we form strong bonds. I've tried to find out how far these abilities extend through the animal kingdom. I've spent a lot of time trying to find out if pet snakes or lizards do this, and very little evidence that they do. They're partly because they're solitary in the wild anyway, and don't form bonds even with each other. But I've tried quite hard and haven't come up with any good stories. I've even run a series of articles appealing for information in journals such as Reptilian International. I haven't come across any psychic goldfish or stick insects either. So far, these examples are confined to mammals and birds with whom we form strong bonds. After my book, Dogs That Know When Their Owners Are Coming Home, was published, which contains the results of these investigations into a whole wide range of unexplained animal abilities, I got letters from all over the world about extraordinary animals. And one of the most extraordinary kinds of story I got was about African grey parrots. With dogs and cats, people often say, if only they could talk. Well, some African greys and other parrots can. And I heard about one particularly impressive parrot here in the United States, a parrot which now has the biggest vocabulary of any animal in the world. It's 1,200 words. This parrot, called Nkisi, speaks in sentences, uses language meaningfully, and is a phenomenal creature. The owner of Nkisi, who's called Ame, emailed me about this after my book came out, and I just didn't know whether to believe her stories or not. It was off the end of the scale of anything I'd heard before. She told me that her parrot could pick up what she was thinking, and it would quite often say things that were in her mind. Most surprising of all, it sometimes wakes her up from her dreams by commenting noisily on what she's dreaming about. So as soon as I could, I went to visit Nkisi and Ame, and I was astonished to find this was true. Everything she told me seemed to be true, and we set up an experiment there and then, and it worked. She looked at a picture in one room, and the parrot then said what she was looking at in another room. We set up a formal experiment to test this, involving hundreds of targets selected by somebody else in sealed envelopes. And the experiment consisted of Ame opening a sealed envelope, looking at a picture for 2 minutes, while the parrot, she was filmed, the parrot in another room on another floor was filmed, no one else in the room with the parrot. Did the parrot say words corresponding to what she was looking at? Well, the answer is in many of these tests it did. Sometimes it didn't speak at all, but it's way above the chance expectation. It said what she was looking at. And I have here a DVD that shows some of these experiments. And I hope it's going to work. We're not quite sure. This remarkable bird speaks, as I say, in sentences. It speaks very clearly, and but of course it has an American accent. And so, because this film was made mainly for a British audience, we've got subtitles.
I've been working for several years to train my parrots to understand and use spoken language appropriately. Due to their ability to communicate through meaningful speech, I discovered by accident that they seemed able to read thoughts. They would often describe vocally what I was looking at, reading, or even thinking that they could not have known of any other way. I had never done anything to try to train or reward them for this. They just seemed to do it as part of their expression of our bond. This was happening so frequently that Rupert Sheldrake and I decided to perform these controlled experiments to study it.
Love you. See you later. I'm gonna go show you these pictures, okay? I want you to tell me.
From now on, the only voice you hear is the parrot.
Oh! You can put the take and blow. See you later. We're gonna go get pick some flower. Yeah, your mother ain't gonna pick some flower. Yeah, they go pick some flower. We gotta go to camp and put some flowers on out. We gotta put some pick some flower. There's some pick some flower. Let's go here, put here, get a flower. Look at pick a flower. Yeah. careful. It puts your head out. It puts your head out. Oh, careful. It's not put your head out. What's that? Oh, can I have your hug? Can I give you a hug? Your hug?
Oh, 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 tickle, tickle, tickle. Oh, 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 I got you. Oh, oh, I got you. Oh, oh. Got you.
Can I have a kiss?
Okay. Can I have a kiss?
Hurry up.
Okay.
I can't reach you.
Okay. Yeah.
Well, the Nkisi goes on learning and is a truly astonishing parrot. Only 8 years old now. African greys can live to 8 to 75. So the most astonishing thing, apart from the telepathy, is the ability to use language in a grammatically correct way. I introduced Nkisi and Aimee to a number of scientists, including Jane Goodall. And Jane Goodall now visits whenever she's in the neighborhood to go and see Nkisi and Aimee. And she thinks this is one of the most remarkable animals in the world, and so do I. This is a really extraordinary situation. This animal, its ability to communicate is extraordinary. And I've spent afternoons sometimes just sitting by Nkisi's cage, listening to his kind of free association. He'll talk continuously, and then he'll react to things that are going on. And these sentences are different each time. As you saw there, they were not just the same thing, Polly wants a cracker, that kind of thing. It was much more sophisticated. And also, when he's learning, he makes the same kinds of mistakes as children. Says things, he gived it to me, instead of he gave it to me, showing there's some kind of grammatical process going on. It's already been proved by Professor Irene Pepperberg that African grey parrots can use language meaningfully. And this surprised a lot of scientists because their brains are so different from ours. And after all, they're literally bird-brained. And so people thought that at first that only great apes would be able to use language, and they taught chimpanzees and gorillas American Sign Language. But parrots have the huge advantage they can speak in English. And I think there's a huge amount more we can learn from animals like Nkisi, and indeed especially from Nkisi. Well, telepathy, I think, is normal and common in wild animals. I think it happens with many domesticated animals between them and their owners. I summarize this evidence in my books, and if you're interested, you can read more of it there. This is also published in scientific journals, and all the texts of those papers are available online on my website, www.sheldrake.org, free of charge. So you can just go and look at anything if you're interested in the technical details or the statistics. I think the same principles apply to human telepathy. I think that it depends on close social bonds. It's a form of communication between bonded members of social groups. Unfortunately, some of the very small amount of work that's gone on telepathy done by parapsychologists has rather ignored the natural history of it. And a lot of parapsychology tests have involved taking total strangers, putting them in separate rooms and seeing if one can read the mind of the other. These tests work, but they don't work very well, and they give very small results just above significance quite often. And I think it's much better to do these tests with people who know each other well. I mean, go with the grain of nature rather than against it. And so therefore, as a biologist, I've been looking at the natural history in the human realm as well as in the animal realm. One place where I think telepathy is quite common and where it serves an obvious biological function is telepathy between mothers and babies. When I first got interested in this, I looked up the literature and I found that there had been no investigations of telepathy between mothers and babies. So I started with a survey by collecting stories from mothers and then with surveys. Now, some of the most dramatic cases occur with nursing mothers and the milk letdown reflex. For the benefit of the men in the audience, the milk letdown reflex is something that happens when lactating women's breasts get ready to feed a baby. Normally it's triggered by hearing the baby cry. And it's an oxytocin-mediated response. The nipples start leaking, or some milk, in some cases, squirts out. The breasts feel different. Some women report tingling sensations. They feel their milk let down. Well, many women who are breastfeeding have had the experience of being away from home, not at a normal feeding time. They've gone shopping or something, and they suddenly feel their milk let down. Most women assume that their baby needs them when that happens. And until fairly recently, they'd just go home. Nowadays, they call home on a cell phone to find out if the baby really does. They're usually right. We did a detailed study with 20 lactating mothers in North London to find out whether or not these letdown events when they're away from their baby did in fact correspond to the baby's needs. We did an analysis that ruled out synchronized rhythms. So we were looking at sort of unexpected letdowns. And we found there was an extraordinarily significant correlation, odds against chance of 1 billion to 1. This is summarized in my book, The Sense of Being Stared At. Many mothers go on having a bond with their children as they grow up. We have endless case histories of mothers who've suddenly felt they've got to go home or they've got to call home just when a child's had an accident. And this continues throughout life in some cases. Women in all our surveys turn out to be more sensitive than men to these kinds of things. And the most sensitive couplings are mothers and daughters. Many, many cases where mothers and daughters seem to retain this intuitive telepathic connection right through their lives. So the mother and baby telepathy is one situation which seems to show a clear biological effect. It's not that the mother thinks of the baby and then the milk lets down. It's the other way around. It's the body responding and then she thinks of the baby. Telepathy works at a basic biological, physiological level. It's not primarily to do with higher thought processes, rational processes. It's a kind of need-based response, emotionally based response. In my surveys and natural history of telepathy in the human realm, I discovered, rather to my surprise, that the commonest kinds of telepathy in the modern world occur in connection with technology, particularly telephones. And I found that in the US, Britain, and in Europe and in South America, about 80% of the population claim to have had experiences of telephone telepathy. In other words, you think of somebody for no apparent reason, then there's a call, and there's that person. You say, that's funny, I was just thinking about you. How many people here have had that kind of experience? Well, again, the great majority. I looked through the scientific literature, and I found this had never been investigated. The only scientific response I came across was the standard armchair skeptical argument that tries to dismiss it, whereby skeptics say, this isn't really a telepathic response. It's simply you think about people all the time. Someone then rings and you imagine it's telepathy and you forget the millions of times you're wrong. Now, they have no evidence that you're wrong millions of times. This is simply a speculative argument with no evidence at all that supports it. And I then tried to set up experiments. I did set up experiments to test if that skeptical theory is true or not. How we do the experiments is this. Imagine you're the subject. You volunteer as a subject. And you then give us the names of 4 people it might happen with, people you know well, family members or close friends. You then sit at home being filmed next to a landline telephone with no caller ID system, and we then pick one of the 4 callers at random, ring them up, and ask them to call you. So the phone rings, you know it's one of these 4 people. Before you pick it up, you have to guess which one. You say it to the camera, I think it's John. You pick it up, hi John, you're right or you're wrong. And by pure guessing, you'd be right 1 time in 4, 25%. In fact, in these tests, people are right very much more than the chance level, over 40%. They're not right every time, because this is a very artificial experiment. People are not ringing because they've got a real need or a real intention to get in touch with you. They're just ringing because it's part of an experiment. But nevertheless, this has worked extremely well, and I've published several papers on this, and it's been repeated in other places in the world. And I have here an experiment that shows a repetition of it for British television. A television company heard about these experiments, and they came to me and said, we'd like to do this for television. And I said, well, do you want to film the people I've been doing research with? And they said, no, we don't want to use the people you've been doing research with. They're just ordinary people. This is TV. We need celebrities. So I said, well, you can't just have random celebrities. They've got to know each other well. And they came up with a 1980s girl band called the Nolan Sisters, who are perfect for this. They know each other well. They're Irish. They have Irish in origin. They've lived together, close to each other. And so we did an experiment for television with the Nolan Sisters on telephone telepathy. And I have that here. Now, let's see if we can get this to work. There we are. If you look at the modern world, despite all discouragement, most people believe that they've had telepathic experiences. And interestingly, the most common kind of telepathy in the modern world is precisely one that's grown up alongside technologies. In other words, telepathy connected with telephone calls.
So many people tell stories of telephone telepathy that Dr. Sheldrake devised a test to see whether someone could predict who, out of 4 people, was calling them. The probability of being correct by guesswork alone was 25%.
We've now completed 1,000 of these trials, and the average success rate is 42%, which is hugely significant statistically. People certainly aren't right every time, but it's way above what you'd expect by chance.
So, is telephone telepathy real, or is it just a figment of the imagination? We brought one of the most successful girl bands of the 80s to London to find out. The Nolan Sisters are one of the closest families in showbiz. At the height of their fame, they spent months on the road together, and most of them still live within miles of each other.
I'm Rupert Sheldrake.
But how well will they do in the telephone telepathy test?
Now, could you tell me all your names in order, please?
Yes, I'm Denise Nolan. I'm the most intelligent one here.
I'm Maureen.
She's just Maureen. Hi, I'm Linda, and Denise is a liar.
I'm Colleen.
Colleen is the youngest, and I'm Anne, I'm the eldest.
Why do you say that?
Because I want people to say I look good for my age.
Maybe you don't.
You don't. Not really.
The first stage of the experiment is to decide which of the sisters will be the receiver.
So 4 of you are going to stay here. 1 of you is going to go to the hotel and try and guess which of the others is phoning. So we've got to pick the person to do that.
It's got to be Colleen.
Colleen is nominated by her sisters because she's the youngest. And while she's driven a mile away to the other location, Dr. Sheldrake allocates each of the other sisters a number between 1 and 4. For each trial, a throw of the dice will determine who will be the caller.
So we're going to start now with the first one. I'm going to throw the die. 2. There you are, Maureen. So you've only got 2 minutes.
Maureen's first up, and the rest of the group must leave the room to allow her to focus.
Let's let me think about her.
When the phone rings, Colleen will have to say who she thinks is calling before she picks up.
Right. Maureen. Maureen. Yes! Oh, yes! Yes! Thank God for that. Thank you. Lovely talking to you. Bye. Bye. I knew she'd get it. Yes. Bloody hell. Oh, sorry.
But that could just be coincidence. Next up is Anne, the only sceptic among the sisters.
Denise.
No, you're wrong.
With 4 sisters to choose from, if it's purely guesswork, Colleen should expect to be right 25% of the time by the end of the experiment.
Think of your favourite sister. The most talented one.
I'm not getting anything now. I don't want to be wrong. Linda. Linda.
Yes!
Yes!
Good girl. You're not thick.
Oh, thank you.
Oh, bye.
Thanks for calling. Bye.
Bye. Yes.
That's good, isn't it?
Halfway through, and Colleen is a long way ahead of the 25% expected by chance alone. Anne's number has come up 4 times, but for the previous 3, Colleen has guessed wrong.
Anne.
Yes! Hooray! I knew you loved me, really.
3/4 of the way through, and Colleen's hit rate has reached over 40%. According to Dr. Sheldrake, this indicates there's more going on than simple guesswork.
Maureen or Linda, I think. Linda. Linda.
Yes! Yes! Yes!
Oh my God!
I'm so impressed.
I'm scaring them now. They're backing out the room.
They should never have gone in there with you, love.
Fantastic. Thank you. Bye. Wow.
Colleen's final score is 50%, one of the highest of over 1,000 tests conducted by Dr. Sheldrake.
Anyway, well done. I think that was great.
Thank
Thanks very much.
I enjoyed it.
Well done, that girl.
Cheers! Don't block my face.
Well, the latest form of telepathic communication that's evolved along with technology is the telepathic email. And we've done very similar experiments involving 4 emailers, people guessing who they're about to get an email from, with very similar results, actually somewhat higher results than telephone telepathy. I now have a series of automated tests. The idea for these first arose right here, actually, in the Seattle area. A couple of years ago, I was in Seattle, and I was asked to give a seminar at the Microsoft Research Center. It's actually one of the things that put me off PowerPoint. It's only Bruce's mentoring that's enabled me to get so far as I have today. Because when I went to Microsoft at Redmond, Washington, to give my seminar, I turned up with my Mac memory stick, thinking that would be enough. I asked them before lunch if we could test the equipment, and they said it's quite unnecessary. In the research center, we've got a state-of-the-art seminar room, every form of... So I said, well, I'd like to test it anyway. And we tried it out, and it just wouldn't work, because it was a Mac memory stick, and they only had PCs. So one of them said, I'll go and try and find a Mac somewhere on the campus. And they did, and they emailed the things over to the PC in the seminar room. And then just before the seminar, I said, look, I would like to test this once more. It still didn't work. And they said, look, there must be something wrong with the system here. And I said, well, you know, it is a Microsoft system, and if you can't fix it, who can? I mean, they're desperately trying to fix it. The seminar began, and they still hadn't got it working. So I said, well, look, I've had so many problems with this that I always carry as a backup my overhead transparencies, and I pulled them out of my case. I said, I think we're going to have to revert to the overhead projector. And then they said, have we still got one? And then 5 minutes into the seminar, there was a trundling noise as a technician came and dusting off the overhead projector. So after that, I thought, well, if it doesn't work at Microsoft, I'll just go back to overheads everywhere. But now, with Bruce's help, I've moved into this modern age. Anyway, one of the things that they were very interested in was the possibility of setting up an automated email telepathy test, which could run on an MSN Messenger platform or something like that, and would have enabled millions of people to do these kinds of tests, finding out how telepathic they are. Some people at Microsoft had invited me because they thought that was a real possibility. They were very, very excited about it. So was I. And indeed, the seminar went extremely well. And afterwards, there were some of them who really wanted to do this. But others said, no, look, we can't do this because telepathy is kind of flaky, and you know, we've got our corporate image to think about. And I said, well, actually, your corporate image isn't that great. And so it went to higher authorities, and they struck down the idea. But I've since been approached by a range of other companies, including most recently Google and AOL. And I've developed already an automated email telepathy test that's running now in a prototype form on my own website. And if this works, it seems to be working pretty well so far. We're getting above chance significant results. This could easily go public on a huge scale. In the meantime, I have to test out the system we've got. And here's somewhere where some of you might want to help. First of all, anyone can help by just doing it. It's on my website. You go to the online experiments portal at www.sheldrake.org. Try the email telepathy test. If you'd like to help further, I have a kind of pyramid selling scheme where you can become a research helper. I'm now funded from Cambridge University, rather surprisingly, for this research. And I can appoint you as a research helper if you think you can recruit 5 other people to do the test. You get paid for that. You also get a certificate of research experience, which helps your CV. At least in some areas it would. To have a certificate of research experience in telepathy. In others, you'd probably better not mention it. If you'd like, there's also on my website information about the Research Helper Program. So try it yourself first, and if you'd like to be part of this, become a research helper. And I have a range of other tests that I'm asking people to help me with, so you can be part of this research program if you'd like to be. I've also developed an automated text message telepathy test for the younger telepaths. And this is now running in North London, mostly with teenagers doing it. Text messaging is more advanced in Europe than in the United States, where it's still mostly confined to much younger people here, teenagers and people in their 20s. But the market's growing here quite fast. And I gave a seminar at the Esalen Institute recently, and a woman who set up a commercial text messaging company in LA was very keen to work on this with me, to develop this as a commercial product. How telepathic are you? Try the text message telepathy test. You get your own score. This is also up and running, but it's not working yet in the US. It's working only in Britain at the moment, the text message test. But watch this space. It could soon become available here. And I have a range of other automated tests on my website. So there's something anyone can do who'd like to take part in this research. Well, that's more or less where I am at the moment with these automated tests, because I think that's the way to go. There's, in trying to persuade people within the scientific world that these things really happen, the problem is really a social one, an institutional one. Plenty of scientists know that animals and people can be telepathic, that they have psychic abilities. They know this because they've experienced it themselves or with members of their family. Lots of scientists, who are after all mostly normal people, when they get home in the evening have dogs waiting for them at the door. You know, they know this is happening, and yet institutionally there's a kind of taboo. So most scientists don't talk about these things to their colleagues because they know they're not meant to believe in them. So they pretend they don't. They pretend to be skeptics at work, but in private they relax and become quite different people. I think actually the main way in which science and medicine will be transformed is not by persuading lots of people in science and medicine that the world's got more in it than current orthodoxy admits. Plenty of them already know that. The problem is getting people to admit it in public. So I think the best model for this is in fact the gay liberation movement. This came to me once. I gave a seminar in a Cambridge University department where they work on companion animal behavior, pets. And there were 6 members of staff, and after my seminar, one after another, they came up to me and said, you know, I really believe this stuff happens. It's one reason I went into this research in the first place. I've had examples of it with my own pets and so on, but I can't talk about it here because everyone else is so straight. When all 6 had told me the same thing, I said to them, you know, why don't you guys come out? You'd have so much more fun. And I think that's what we should all be doing, trying to promote a kind of coming out movement within the scientific and medical communities, because there's plenty of people who are open to these things. It's just that they're afraid at the moment. It's like gays in the 1950s. And I think that, I don't know quite how this should be organized. I mean, you know, gays used to have those glad to be gay button stickers, you know, happy to be holist, something like that. But I think a coming out movement is what we should all try and promote. And anyone here can help. If you work in a professional organization, just talk openly about these things. You'll find most people agree with you. And it's a huge relief to break through this taboo, which is still very strong in our society. Well, I think I've said enough to show that there's a lot of new areas in science to explore. There's new models available, more holistic models in science and medicine. Paradigm shifts can only occur when there's an alternative model. People are not going to give up one that works up to a point in favor of nothing, but they can give it up if there's an alternative model. There's alternative ways of doing this research. I myself have spent a long time trying to think of cheap and simple experiments because it's very hard to get this kind of research funded. But one way of dealing with that problem is to try and make it really simple and inexpensive. And most of the experiments I've talked about really are very inexpensive. And the Greek word one you did today, you see, it costs very little, photocopying, my research assistant's time in marking them. There's not much more than that. The telephone telepathy ones don't cost much. The email telepathy ones are virtually free. So there's plenty of work that can be done, plenty of things that can be investigated. And I think we stand on the threshold of a really exciting new period of scientific development. Now there's some time left, and now is a time when we can have questions and discussion. If I had longer, I would have wanted to do more experiments with you, but we don't have time for that. And so what we'll do for the questions and discussion is, like last night, if you want to ask something, please come up. There's 2 microphones here, one on either side. And I'll try and answer or comment on what you say.
Okay, I have a question from remarks you made last night, which is, if I understood you correctly, you said that there's evidence that plants under certain circumstances will increase their mutation rate highly and also direct the mutations or have mutations that are helpful to the plants, which of course is very much in opposition to the random mutation natural selection model. So I'm wondering if you could talk a little bit more about that and also indicate where you might be able to find non-scientific explanations and
Okay. The example, I'll just give one example. It was discovered last year that in the plant that is most studied by scientists called Arabidopsis, it's a small plant. It's like the plant equivalent of the fruit fly. It's what botanists like to study because they know the genome. It has a short generation time. In Arabidopsis, there's a flower mutation called hothead, where the petals fuse together, and the mutants are called hothead. And it's a double recessive. It has normal kind of Mendelian inheritance. But they noticed that about 10% of these plants were reverting back to normal. The back mutation rate was 1 in 10, whereas by chance it should be like 1 in 10,000 or something, or 1 in a million or 10 million. So how was it that they were reverting back at these hugely increased rates? This was done at Purdue, and they found that because they knew the whole genome, because they could sequence everything, they also ruled out accidental cross-pollination, all the trivial explanations. They came to the conclusion there was a hugely enhanced back mutation rate that couldn't be explained by any known mechanism. They then postulated an explanation that there's a parallel system of inheritance in plants consisting of cytoplasmic RNA, which contains copies of all the genes and can correct genes when needed. Now, this is a very radical suggestion. It goes against all the normal dogmas of biology, and there's no evidence for it either. But they're driven to this extreme position by the evidence that they got for this back mutation rate. I think that morphic resonance could provide a much better explanation. But this was published in Nature, it was in Science, it was in all the leading scientific journals. And if you want to get into the literature, do a Google search on hothead Arabidopsis, and you'll get into this literature. And the paper in Nature also reviewed a whole lot of other anomalous inheritance phenomena in plants that they think could be explained in a similar way. So this is a quite recent discovery just last year, and it was reported widely in the scientific press. It wasn't in the sort of non-scientific press much, but it's a radical discovery. There's also been a lot of studies on directed or seemingly purposive mutations in bacteria, which is also very controversial, but also is backed up by lots of evidence.
And so far, on the second of that, the bacteria, is there? Where would you look for that?
The key paper was on directed mutations in E. coli by Cairns, C-A-I-R-N-S et al. And again, if you do a Google search, you'd be able to find that literature.
Thank you.
2 disparate questions you can choose. One of them is, last night you pointed to the discussion of the field. So I'm curious, one, if you could address your feeling, I understand the outside of the mind, how is that information possibly transmitted? I'm curious if you wish to speak to that or not. And secondly, is within the literature, given the thoroughness of your experiments, are you finding a willingness to be able to break the cronyism outside of the parapsychology journals into the more scientific, and are you finding any shift in that arena? Because that is what's going to have the shift happen, I think.
Well, first, I think the fields work rather like morphic fields. They're probability structures. they connect things at a distance, they have something in common with quantum non-locality. If you think about animals that have been part of a social group, well, like a dog and the owner, for example, they're they're socially bonded, they're together most of the time, they go apart, and a change in one, the owner deciding to come home, affects the other. Now, in quantum theory, quantum non-locality or entanglement occurs when particles have been part of the same system, they move apart, the change in one immediately affects the other, with no fall-off with distance. And that's true of telepathy as well. So that's certainly the closest physical analogy. When it comes to scientific journals, I try to publish my work in mainstream journals wherever possible, but it's not always possible. And for example, it depends on the editor. It's very capricious. So my email telepathy paper, which is based on hundreds of experiments, a lot of data, statistically analyzed with the help of professional statisticians, I submitted it to the British Journal of Psychology. It was rejected instantly on the grounds that it was of no interest to their readers. I then submitted it to Perceptual and Motor Skills, an leading American psychology journal. They sent it out to referees, they made a few comments, I modified it, and they printed it. So sometimes mainstream journals will publish it, sometimes they won't. It's really the luck of the draw. My dog research, I sent a paper to Animal Behavior. I got a letter back from the editor by return of post saying, no reviewer for this journal would consider a paper that mentions the word telepathy. I'm therefore rejecting it without review. So that's common. But there are some editors who are more open. So luckily there's lots of scientific journals. But actually, the problem with scientific journals is that nobody really reads them. And so I think part of it is a social problem, getting these things out into the media. The media are heavily influenced by these skeptic vigilante organizations. USA Today, for example, did a rather favorable article, a one-page article on my research with pets. Within hours, the SciCop, the skeptic organization, had their press officer on the phone to the editor saying, you've discredited your paper by reporting this stuff. This guy's a charlatan. This stuff is pseudoscience and so. Allegations for which they had no evidence at all. They hadn't read my papers. They didn't need to. They know the truth. So they tried to browbeat the editor into never reporting anything like this again. This is their technique, and they're very, very effective. I know this because the reporter told me about it. And I then wrote to the editor and explained, where these guys are coming from. Incidentally, if any of you have had problems with these skeptic groups, take a look at a website that a number of us have set up to deal with this, called www.skepticalinvestigations.org. Skeptical investigations, all one word. One of the things we do is investigate skeptics. And it's a very good website. I think it does help to restore the balance. These skeptical vigilante groups do not speak for the majority of the science community. They pretend to. But in my experience, most scientists are actually quite open-minded. It's just that the gatekeepers are very keen to keep these taboos in place. That's why this coming out type movement would take the ground from under the feet of the people who rely on a kind of conspiracy of silence on the part of the silent majority or minority within science and medicine.
I'm a doser. I work with a pendulum with animals, and I was wondering if in relation to fields, if you can tell me how you speculate by what medium or pathway the information travels from thought to the pendulum, and likewise from the animal that I'm reading to the pendulum, and how it can record the information.
Yeah, it's a really difficult question, and the answer is I don't know. I've tried dowsing myself, not with a pendulum, with rods, and not remotely. I've tried dowsing for water and buried objects, and I found it works, at least for me. Lots of people can dowse. My assumption is that the field of our bodies picks this information up, and then it moves the muscles so that they give us a sign through the rod or the pendulum as a means of amplifying what we unconsciously know through, not just through our muscles, but through the fields of our bodies that influence the muscles. How one would find out that information from an animal, if the animal's there, then I suppose it could happen intuitively or telepathically and then be reflected through the field. If the animal's at a distance, with animal communicators who don't know the animals, it's rather mysterious to me how this works. Normally telepathy happens between people who know each other well. There are people who are psychics and sensitives and communicators who seem unusually able to tune into people at a distance. This is not normal and not common, but some people seem to be able to do it. And again, it would have to be through some kind of field connection, but I just don't know the details. And dowsing is a very mysterious phenomenon to me, at least distant dowsing. So I'm sorry I can't give a full explanation, but I do think it must be field-related.
Thank you. I was curious in terms of morphic resonance and habit, how you think about habit breaking, because from your crystal example, it seems like the hardest part about breaking a habit would be the first time, and then it would become successively easier to follow your original habit-breaking act. But in fact, you know, the urban legend is if you can get past the 28 days, then you're in the clear. That it seems like it's, even though initially you start out on a roll, that after a while you kind of revert back to your original habit.
Well, habits are very persistent by their very nature. With a new crystal, you're starting with a compound that hasn't got any habit at all. You know, you're starting with a new phenomenon, a blank slate. And what we do is see habits build up. To break old habits, generally speaking, need to interrupt them in one way or another and then replace them with new ones. And that's not easy, as any psychotherapist or anyone who's tried to change their habits knows. I think a more general point that arises from this is that the whole of nature is habitual, but habit alone can't explain evolution or creativity, because evolution must involve new things happening, and so must personal evolution, our own personal development. I think we're all, and the whole of nature, involves an interplay between habit and creativity, that we can only create new things or new situations when the old habits have been blocked or interrupted in some way. Then new possibilities emerge. Then one of them is selected and repeated, and that becomes a new habit. And so what we find really is this interplay always of habit and creativity. But without particular vigilance or without finding new habits to replace them, old habits usually come back sooner or later.
This question is about semantic resonance and semantic fields. Or no, morphic resonance. But so I'm a psychotherapist, and I have a number of clients who have come back in, and one in particular I'm working with right now who says no matter what he does, he keeps connecting with women who end up being like his mother. and they seem different, and we're trying to work on his part of the dance, but I keep wondering if there's a way to help someone. You talk about the way a field is set up, and I keep wondering if there's a way to help someone change something that's not only part of their dance, but that is in the field that they grew up in. And I'm thinking of also the intergenerational field, because it sounds like there's some patterns coming down in the generations in his family.
Well, I'm not a therapist myself, and I can't give any immediate practical suggestions, but the therapist who's interested me most is a German family therapist, Bert Hellinger. And Bert Hellinger, who does systemic family therapy, gets the person who's interested in doing something sets up a constellation of their family. They pick someone to represent themselves, the mother, the father, their brothers, sisters, and other members of their family group. They then place them in relation to each other. It's a kind of model of the family field. And Hellinger thinks of it as creating the family field right there. Then you can see how the people interact. It's fascinating to see this happen, because the way they place them, immediately just by looking at it, you can see how they're related to each other. You know, sometimes you have someone, the person places them way out, away from all the other members of the group, looking out. And then he goes up to that person who's standing there and says, "How do you feel in relation to the family?" And not surprisingly, they say, "I feel kind of isolated, as if I'm looking somewhere else. I'm not connected to them." And that's just what that person in the family was. And he finds that by doing this, he can find patterns in family fields which are inherited from previous generations. Because by morphic resonance, there's an unconscious inheritance within the field of the family. One of Hellinger's most interesting discoveries is that many disturbances in family fields occur through people in past generations who've not been acknowledged, people who've either died young, committed suicide, or who've been airbrushed out of the family history, people who are there but have not been properly acknowledged. This sets up appalling patterns, and in subsequent generations people sort of repeat patterns that they're completely unconscious of, and so are other members of the family. But when you can trace them back to a previous generation, what he then does is changes the field by moving people around, has them say things to each other. "I recognize you." He brings in the missing person, puts them there. These have astonishing effects on the whole family balance. And quite often, Hellinger and his colleagues tell me that someone who's been there, they've done this therapy with them, they go home, and someone they haven't heard from for years, you know, long-lost cousin or somebody, or brother they're estranged from or something, calls up and says, "I just felt I had to call. I felt something had changed." This is a very fascinating field. Of all the systems of therapy I've come into contact with, this is the one that seems closest to the morphic field idea. Whether that would help, I don't know.
It does. Thanks. I'll look up Bert Hellinger. Okay.
Hellinger, systemic family therapy. There are groups in America that do this.
Hi, Rupert.
Hi, Mark.
I was wondering, you spoke last night about a type of small-celled animal that would change its shape, morph its shape based on external factors. Even though, of course, its DNA hadn't changed, it was able to it changed its shape profoundly. Due to limitations of time, you might not have gone into perhaps how a skeptic would see that. A skeptic would say that, well, couldn't it have been that a different part of the DNA was triggered, and so, yes, the whole structure of the DNA didn't change, but simply due to the external event, a new portion of it is now activated. Yes. I was just curious if you could maybe elaborate on that. Thank you.
Yes, I mean, I think DNA is triggered, and the morphic fields and the way that cell membranes and the fields of the whole cell work is partly by activating different proteins being synthesized in the DNA. I mean, shouldn't give the impression I'm against genes or think they don't do anything. They do. They code for proteins, and they make the right proteins at the right place at the right time. But they themselves, they have to know how to do it. It's the field that controls the DNA rather than the DNA controlling the field. So that's part of the process. The changes in these unicellular organisms, Naegleria, 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 this particular species is called, these changes are triggered by the environment, and the membrane begins to respond quite fast. And it may be it involves new proteins being made. It may not. I mean, the way to test that would be to see if it still changes even in the presence of protein synthesis inhibitors. But from the point of view of morphic fields, it's not either or, it's both and. It involves fields and genes. The problem with the conventional view is it only involves genes, and it leads into all sorts of problems and incoherences. So inheritance, I'm saying, involves both genes and morphic fields. They work together, and the morphic fields help to modulate and affect the activity of the genes.
So I wanted to reflect back on yesterday where Bruce talked about doubt and sort of the inverse of that, the power of positive intention.
Yes.
At the individual level. At the more macro level, we have a notion of field. And field inherently controls the components of the field. A magnetic field controls the filings, as an example. How do these two notions come together? How does the sort of notion of free will on the one hand and participating in a constellated field on the other one actually kind of coexist? And I'll just jump to a potential. The work of Alfred North Whitehead, again, and we've had the 20s has been sort of a theme, I've noticed, sort of talks about the fields in your parlance being in potentia, and that the intention is in the individual, and this is arbitrated by feelings as the arbitrator. I just wondered where you would go on this kind of, because to me they seem to be, you can't have complete free will if you're within, a component in a field, as the birds can't as part of a flock, for instance.
Well, I mean, the debate as to whether we have free will or not has been going on for centuries, just in conventional forms, and I don't think this is going to solve it for us, because any view of free will has to admit that a large amount of what we do is conditioned by our environment, our heredity, and so forth, our social circumstances. And there's always grave limits on how much real free choice we have. Now, of course, there's certain kinds of rather trivial free choice that are common. I mean, American supermarkets are based on this principle. You can't just have one of anything. You've got to have 50 different kinds. So the tyranny of choice is something that overcomes me in America quite often. But the serious choices, important choices, are ones where what we have, I think, in our consciousness are alternatives, alternative paths of action. Consciousness is about considering alternative possibilities or potentials and choosing among them. Whether any choice is really free or not is very hard to decide, but we all have to believe that at least some of our choices are free. I think in choosing between morphic fields is in part like choosing channels on a TV. There's all these alternative forms of behavior, all these alternative lifestyles, choices, religions, philosophies, worldviews, social groups we could belong to. Each has its own field. When we enter into one, we become part of that. But we could choose to belong to a different one. Now, in species of birds that are part of a flock, they don't usually have the choice about belonging to the flock or not. They could perhaps choose to fly away from the flock. Indeed, sometimes you see birds that do split off from the flock, but they usually come back again. But with social animals, staying together is the entire key to their survival. That's why they stay together. It's why we stay together. We can't survive as isolated individuals, and nor can most individuals of any social species. In that sense, we have no choice about being members of the social species, although some people are definitely more solitary than others. So these traditional philosophical conundrums about free will and choice take on a new light in the context of morphic fields, but we still have the problem of understanding the balance between conditioning and freedom. And there's no clear final answer on that one.
I think what we'll do is we'll break for lunch now, and I'd like you to just help me welcome and thank Mr. Sheldrake one more time.
Son of a bitch! Goddamn!